You can still hear us, Isabel?
Yeah,
Yeah.
I can still hear you
Yeah.
very loud and
Yes,
clear.
good.
Can still project now on the screen? No,
Of course, yes.
Yeah,
You
yeah,
share
okay, yeah.
whatever you need to share. You share as normally you do.
Right,
I think.
yeah.
Okay, thank you.
Okay, from our side, we are complete. Just let us know from your side when you will
Yeah.
be.
We wait Jean-Christophe and Bernard.
Yeah, I was
Yes.
going to say.
Yeah.
One second. Ignore mine. Okay, we start.
Yeah, I would. The key person I would prefer to join is Jean-Christophe. I'm not sure Bernard will be able to
Then we
join.
wait. And we
But
wait, no problem.
I see that
Yeah.
Bernard did not respond to the meeting, and neither did Jean-Christophe. But Bernard is
Yeah, but
offline.
Jean-Christophe is on another meeting, but I will have a look.
Yeah.
Jean-Christophe.
Okay, Jean-Christophe will arrive.
Okay, thank you.
You want to put the Gantt chart up?
Yes.
That will be the.
Yes, we have two topics to discuss. One is the inputs that we share from our side if there is something missing. And the second one is the Gantt chart, the preliminary Gantt chart that have been shared by Tran.
Yeah.
We have several questions
Yes.
there.
You can call me Son. It's more simple.
All right. Thank you.
Okay, Son. I'm Son. Today is
Maybe we can start with our input. Okay. Raju, can I start with the input you share? Let's ask him if they need.
This okay?
Yeah, let's go. Sorry?
Is this okay for them?
No. It's still to arrive. Just organizing before, then we can launch it. Okay. Yes, we are complete.
Hello, sorry, I was stuck in another meeting.
Hello, Jean-Christophe.
Hello.
Problem.
I don't.
Okay, I guess
Yes.
we can start, no?
Yes.
Daniel.
Yes. Let's go.
Let's go.
So, two topics on the agenda today. The first one is the inputs we have shared with you over the last week. You have shared several inputs. Second input is, and second topic is about the Gantt chart.
So the input which we have shared, is that okay? Is this some? Is there any clarification is needed?
You want to go over? Do you have the time to check?
Sorry.
Hello?
Son, that's mainly a question for you, I guess.
Yes. Sorry. Yeah. Okay. With a minute, I need to close this Windows. Sorry. 1 minute.
Like, when I was sharing the input, I don't know who is the right person for that.
Yes, it's me.
Input to share.
It's
I
Son. You have
it's my it's
to
me.
share.
Okay, I'm going to open the private. When I open the Outlook, is a lot of windows open at the same time. I need to check it. It's yeah. Yes. For me, is which is is when I may. Sorry. I'm sorry. Maybe. I just checked the composition of the materials from the input side, and I need to reopen it. What happened? Not open there. I'm sorry. My Outlook is open. I need to close it and reopen. Okay. Hello? Do you hear me? I'm sorry.
Yes.
Was there technical problems? Okay. Yes, I it's in here. Salim, you sent us the composition of 3 materials of ENT, and I check it. I can consider it like the input for our for the input for EF model in this case. The first column for the first material, I see the content of steam is quite high. I think it's good for a model, and for the scenario, the third and the second and the third scenario, I need the content of carbon is quite high. And for these materials, to adapt with the model, I need to do some adaptation to recalculate the equivalent carbon, to adapt with our models. But for the first data with model, I
Maybe
need
I
to check.
will explain a little bit more, Tram.
Yeah.
What is that first, second, and third? Okay. What is that first one? Scenario 1 is chemistry,
Yeah.
which generally, in ISO standard also made a specification, okay, for wire rod requirement. What is the wire rod chemistry needed to draw thin wires? Okay. So that chemistry, what is the Bekaert requirement? We generally ask our supplier. okay,
Yes.
and which does not have the rubber and nothing. It is a current chemistry which we usually ask supplier, steel makers, and they produce wire rod following this chemistry. Okay.
Could you explain for the first scenario?
First scenario,
Yep.
first scenario is nothing new, nothing to do with anything with the ELT steel. Okay.
Ah,
The ELT
yes.
steel is the sample. Meaning ELT steel is the project we are we are doing the discussion. But before using the ELT steel, we want to know what is our current chemistry, what we have in the wire rod, what we are purchasing. Okay.
Yes.
And that's your, in the reference EAF steel making. For you, the reference is this is the steel make. This is the level of chemistry we need to aim for in EAF. Okay. Okay. Of course, you will not reach the chemistry in EAF, but this is the level of carbon you need to finally you need to achieve in the final steel making process.
It is the current situation of what we buy today to make a steel cord. Okay.
Ah, yes. Okay. Okay.
Yeah. Okay.
Yes.
Okay.
And the second scenario is the calculated chemistry. We just put the manual calculation. Okay. The carbon, it looks like 2.5% is probably is coming from, it is the calculation we make with the level of rubber also influence in the steel. For example, if the ELT steel, okay, assuming the impurity level of 3%, this is the market, what we understood that, in the ELT steel, the impurity level, impurity is, we are calling as a, the rubber content, the other residues coming along with the ELT steel.
Yes.
So that is the impurity. We call it as ranging from 3%. It can go to 13.5%. Okay.
Yeah.
So 3% we call it as a one scenario 2, and 13.5% is the worst level of impurity. It goes with the scenario 3.
Yeah.
Okay.
It represents high quality and low quality spread.
Exactly.
Yeah.
So this carbon 2.5% is more or less is coming also from the rubber content, because rubber also is full of carbon, right? Yeah. So 2.5%, carbon, which we don't want. We want to have finally the scenario 1, which is 0.8%, 0.7% is the carbon we need to get it as a wire rod level, because this is the requirement.
Yeah.
Understand? So, but in the sample, we might be having 2.5%. Okay.
Yes.
And
Okay.
the percentages are calculated, Shaju, from the steel weight.
Steel weight, yes.
Yeah, because.
And in the ELT steel, there is no other chemistry we are adding up, like manganese. I kept it as the same. Silicon, I kept it as the same, because I assume that the ELT steel, which more or less not only Bekaert, all the supplier, whoever is producing this the wires for a tire, more or less we are following the international standard for producing the wires. Okay. So whatever available in the steel recuperated from the tires, more or less following the reference level of the other chemistry like manganese, silicon, phosphorus. There is a sulfur which is little bit adjusted because the sulfur is also coming from the rubber.
Yes.
And chromium, I did not change it. Copper, nickel, moly, nitrogen, aluminum, tin. I put it here is same, but the thing is, we don't know how much is the influence here. Okay.
Yeah.
Then arsenic and zinc is same. So, sorry, zinc and the other contents, whatever in the bottom, which is all input, what we have as a reference for content in the rubber.
Yeah. Okay.
Okay, and that's all based upon the purity level, impurity level in the ELT separation process. I put the levels accordingly to the high quality, like 3% impurity. How much would be the influence from the rubber, and 13.5% impurity. How much is the influence? So that is the level of percentages. I just put it here. Okay, is this clear now?
Yes, much more clear for me.
So so Saju is just a mixed law calculation of going from a standard composition to the percentages of scrap that
Exactly.
could impact the final composition. Yeah. Okay.
Well,
Yeah.
correct, isn't it? And the copper of the coating is also involved.
Yeah. I was going to ask. It's the copper in the coating. Yeah.
Copper,
Yeah.
you can see copper. There is an influence in the copper.
0.2. Okay. Thank you.
Okay.
Okay.
Is there anything else you have a doubt?
Something. Sorry.
Ron?
Sorry.
Do you have any other doubts?
Is it okay for you, son?
Yes. Okay. I understand.
Is that clear? That's clear.
That's clear. Okay. That's much more clear now. Okay.
You don't have any doubt in the bulk density or sizes or nothing, right?
For density, do you have, Bruno, you have some idea for this information? For the bulk density, for the size?
Who do you ask?
Here for the input data, we have the bulk density is 2.8 ton per meter cube, and the size. We need to prepare the compact test with these materials. And what do you think?
Yeah. When do we receive it? When should we receive the material, or did we receive it yet?
No, I did not send yet the sample.
Yeah. Mm-hmm.
Okay. We will once I send it, I will let you know. But we are also waiting to get the new sample. I will once it is dispatched, then I will let you know. I will arrange in 1 or 2 weeks. 2 weeks time.
It's 2
arrange
weeks.
it. Okay.
Okay, thank you.
Yeah, but okay. But even a small sample, just to have a look and see what kind of roof press we can use and what kind of compaction equipment we can is more suitable to your material, because depending if it's fine or it's big particles or more
Let's-
hard particle or more soft
Yeah.
particles, so it will
Discuss.
it will make the choice of the equipment.
By the way, for the
Yes.
simulation, we could already start with some data we
Correct.
have from other plants, and they are already
Yeah.
using some wires. So in the strap file from other plants, we have some data about density and so on. So it's possible to make some guess and start the simulation as that. Just correct when we have the actual value. It
Yeah.
couldn't be so
And so-
different.
Yeah.
And so
Yeah,
the
the
values, I
sample-
think that's
Sorry, the
Sorry.
sample might be a reference, but the thing is, it can, the sizes and bulk density all will be depending upon our, the final, which is the best optimum level we need to follow. That we don't know, that we need to understand over the study, right?
Mm.
So which
Yeah,
bulk
sure.
density will be okay, which level of size will be okay, all everything will be
Skill.
come to understand in the sensitivity analysis, right?
Mhm.
Yeah.
Okay.
Yeah.
Yeah.
It's clear.
Maybe what we can do now is to go to the
planning.
to the schedule. Yeah.
Mhm.
So
Right. Thank you, Salim.
Yeah, thank you.
will somebody project it or should I?
do I need to project it?
Let me check it. Let me project it. Yes,
Yeah, so I'm already projecting.
I'm already.
Yeah.
Daniel, you project or?
Are you
Yeah.
Are you sharing also, Daniel, with the rest or not?
Okay. Let me check. Let me open it.
Maybe you can see it now here.
It's we're seeing a
No.
screen of the participants, so you might need
that's
to
the
share a
Teams window.
different screen. Yeah.
Stop sharing. You see
Yeah,
it
that's
now?
it. Yeah, much
Yeah.
better.
Yeah. Okay, you have some question here. Okay, let me explain.
Yeah.
Okay, to focus because on the focus localization. Okay. Okay.
We just start having a look. We had a look at myself. I just add some red colors just for me for better understanding and just to make sure we have the same alignment. Okay, the first one is very clear. Definition of the base case on historical data to have a reference furnace. No, so we are saying this will take from now to the first week of April. So I suppose then on the first week of April we have a follow-up meeting to verify this result, to understand what is your choice in terms of the reference furnace and so on. Is that correct?
Yes. For the first work package, 1.1.
Yes. Now, the second definition of the first alternative scenario with sensitivity analysis. Can you explain a little bit more in detail what do you mean with this?
Jean-Christophe, could you help us? It's more details on this
Yeah, if you
work
want.
package.
So the idea is to start to, as you said, to define a base case with a representative furnace, let's say, of Western Europe production for wires. So that's the first task. And in the second task, we will add the wires and take some hypothesis onto the size, the composition, as you said, the carbon content is not fixed, the sulfur content and soil, and so on. So this addition of material and the the features of the material will modify the outcomes of the furnace, so the temperature of the melt, the composition of the melt, and so on. So that will be seen by this second test. And the third test will be...
Excuse me, just to understand. So on this one, you will use the composition that have been shared by Shayu, is that correct?
Yeah.
Okay, and then you will start have some preliminary results. I have a small question because I see on the, but I want to understand also from those steps is which potential input or data do you need from Becat to make sure that we don't delay any one of the steps. So from what I understand from this 1.2, our input is already shared, is the chemistry of the ELT still, no?
It's the chemistry and also the order of magnitude of the variation in this chemistry. You said that, yeah, the carbon content may vary between 0.8 and 2%. Maybe there are some other elements that would vary. As well, the bulk density should vary depending on the compression that is applied to the material. So all of this range of values should be known, so we could perform the sensitivity analysis and not just using one value, but performing modification of the different parameters, but in ranges that are sensible. There is no sense to consider 25% of carbon into the wires. We need to know what is interesting to test.
That's for 1.2.
Yes.
Yeah.
And for 1.3, I will explain. In this work package, we will evaluate the impact of energy consumption, for example, the tap time and tapping carbon, tapping temperature with the new input of data, and we will also adapt. We will try to also adapt the process parameter to recover the KPI or control the charm element. In this case, to evaluate the circularity evaluation in this work package with a new type of scrap from the ENT.
Okay. And then the 1.4 is the additional scenario for verification, correct?
Yes.
Yeah, and also we could test scenarios like position into the basket, depending on where we want to charge the wires into the basket or things like that.
For example, different levels of bulk density, in which parts will this fit?
1
or
to 2.
different composition, 1.2.
Yeah.
Okay. Is that clear for you, Shayu?
Yeah, it's clear, but the thing is, we have multiple factors playing a role, right? So if we are able to, see all the factors, how we are going to do this design of experiment, I think I'm just calling as a design of experiment because there is a factor of bulk density, there is a factor of size, there is a factor of all the variation in the chemistry, different level of chemistries. Okay.
Yeah.
So all these factors, how we are going to make the combination, factor A, this level high, and factor B, this level low, and this type of combinations we make, right? So this one, could you able to share with us?
I guess we need to
Yeah,
share
so
the conditions, no? We need to share the...
No, please.
Go ahead, Jean-Christophe.
No, I just mean this should be in the 1.4. In the 1.2, we perform some sensitivity analysis on each parameter, and then at the end of work package 1, we could test a complete scenario with a combination of several.
Some of these scenarios can be related to the steel making configuration, as Jean-Christophe mentioned. It could be, where do I put in the basket the material? Also, then other scenarios is the condition of the ELT, the characteristic of the ELT. And what about the impact of the amount of ELT? This is also there in 1.4, correct?
the quantity of
I imagine this in 1.4. Yeah.
Yeah, okay. No, that's very clear. Now, I have one question regarding 2.2, because my previous understanding, it was that you need this thermal conductivity characterization for using as an entry property for the work package 1, no? Or even to start 1.2, correct? Is that correct? Or probably I understood wrong from the past discussions.
No, again, it's possible to make some assumption to start, but it's better to have it. Indeed, maybe the date is a bit late now. We should have it sooner
Because
to check.
It seems
It's probably too late.
It seems linked to the work package 2, which is the trial of lab casting. For me, that item is much more related to the work package 1.
Yes.
Because we need this input for, So it will be important to understand, when you will be doing this testing, because it will help us ourselves to organize what is the last deadline to provide you the material as well. So that should be up on the organization. I don't know if it's a requisite for 1.2 or for 1.3. That's up to you to let us know. And then just tell them how long it will take you this analysis, how long it will take you the analysis, so we can for sure provide you the material before that time.
Yeah.
I would say for 1.2, we need it for 1.2. The analysis is quite fast, as far as I understand, because it's done in another department. We don't perform it by ourselves. It's done in another building of CRM. But I understood it's quite fast. It's a few days to have the results, so it's quite easy.
And it should be prior to 1.2 or 1.3.
It should be in 1.2. We need it for 1.2, so it should be prior to 1.2, or at least during 1.2, which would start.
Okay, because you could eventually start with
that.
You can start with
we could start with a theoretical value, but then we need the actual one during the during the task.
Okay, now it's more clear to me.
Yeah.
So we will need to adapt then that one on the plan. The second one I put it there on the compaction test is that I'm not sure it was fully clear on the previous discussion. For the moment, it is not our purpose to do compacting trials in CRM. Our purpose is to bring you the material compacted already. No? That was initially in the quotation and doesn't matter. That budget could be used eventually for adding some additional simulation of additional scenarios as well. So, but for the moment, I would not. I guess we will not. But let's wait also for this one. Let's wait that you also receive the sample and try to understand about it.
Yeah.
To see how we decide that. No?
Okay. Take note. Yeah.
Well, on our side, you perform the compaction. We do it just the same, as long as we have the material in line with the expectation. It's okay. We just use what you provide.
Yeah, I think the whole idea there was to first see the samples, just to get a better feeling, and then decide together, I think. So it's a bit, hypothetical to try and have this discussion now. I think it's something that we need to. What I wanted to come back to the previous discussion also still is that the values that were given now with regard to bulk density and size and so on, are they sufficiently in the ranges that we have worked with up until now, or are they really outside those standard ranges that we have been using in the model?
We have data for similar material.
Yeah, okay, so yeah.
Probably not exactly the same, but
No,
okay.
that's not what I'm
Yes.
aiming at.
But,
But if you can already understand whether it's in the same.
Yes.
Now, of course, what is true, as you are saying, Isabel and just Christophe, is that as explained by Shayu, one of the ideas is also to understand what will be the critical characteristics of the ELT. Probably what we are ourselves today, based on the industry experience and based on what is in literature, let's say striving as a ball density, maybe it be too low, and then on that moment probably we will run the trials on your press.
Yeah,
That could be a possibility, but of course here what we are aiming is we will be aiming on the less compressed possible sample that make the job.
Yeah, and it's a little bit, it will be an iterative process. You will need to be able to understand when it gets into a certain range, but it has a huge impact or no impact at all.
No impact.
Then it becomes a balance between what is the technological result and what is the financial impact of that extra pretreatment. So no, but I think it's really way too soon to make such assumptions. And to that extent, I understand that perhaps they were foreseen a little bit later in the Gantt chart, because we might first want to get a feeling with some theoretical values. And but
you were assuming
speaking before my turn. Yeah.
So you are assuming 2.2 to be the thermal conductivity of a final optimized sample in this case. Okay.
Yeah, but I think what concerns the 2.2, I agree with Jean-Christophe. It's another lab that has to do it. It's a lab that is used to doing service-based tests. So I'm quite sure that if you can provide a sample, and it doesn't even need to be a very big sample, we can check with them. We will already have to check with them, because that's what I remember from the technical discussions. What is to what extent is the sample usable in its delivered form, or will it be necessary to compact it in any case, because you need a certain contact surface, a certain flat, relatively good quality contact surface to make the measurement, just to be capable technically of doing the measurement. But apart from that, it's not their test that is going to be the limiting factor. So that's something we could bring forward with regard to the compactation and the shredding and the eventual need of it and so on. I think it's more relevant to try and first in the different steps of the model to try and see what the real impact of that is before engaging in some kind of broad material testing matrix where where you don't see the beginning and the end neither. I think so. It's a personal feeling I have. But
you mean for 2.1? You mean from 2.1, Isabel, correct?
Yeah, for 2.1.
Yeah,
but 2.2,
I agree.
But 2.2, I agree. It might be because it's a parameter with which we have perhaps a little bit less intuitively the feeling what the impact could be and how the material could exactly behave. That is an interesting one to measure. I think the density is something I think that like a little bit more, sort of based on common sense that we can understand what could be, but the thermal conductivity, since we can measure it, why not measure it straight from the start and use that value in the model? I think that might be a good approach.
So, do you also need a sample without compacted the loose samples
It will
immediately?
be important. Yeah.
That is immediate. That is also you need as soon as possible. Is this my understanding correct?
Yeah.
Yeah, should be
Yes,
good to have
yes,
both on the loose
yes,
and the
yes.
compacted one as soon as possible
Yeah.
to see
Because that will be our kind
they
of
look like.
our range for
Yeah.
ball density. The one that is loose completely, the one close to 3
Yeah,
that
yeah.
we are on today. Mm.
Yeah, and we really need to check with the technician who does this measurement when it's in a sort of loose state, whether, as I say, if it's technically possible to measure it in that loose state or not. So
Yeah, but anyhow,
So
we will make sure the samples on all the conditions are available, because otherwise we make both of them available, loose and compacted.
yeah.
Let's go back.
And could you please tell me how much? So last time you already told that one sample is okay for the compacted one. For the loose one, how much kilogram?
Few kg, I don't know, maybe 10 kg to be sure, but it's already a lot. Yeah.
Yeah, 10 kg is okay, right?
Yeah, sure.
Yes.
Okay.
We don't need a lot.
Yeah.
Just to feel it.
Because I'm just thinking, if you want to make a compaction test for a different sizes, then it will not be.
That's for later.
That's okay.
It's not
Yeah,
now.
Yeah,
no,
but that's-
this
The
is just
compaction is for
for
later.
Okay. Okay.
It's just to check thermal conductivity, to really to feel how it behaves, but not for compaction right now.
Okay. So I see the 1.2 and the 1.3 will be planned in the April. 1.2. So maybe the design of experiment will be ready before this, maybe in the April itself, right? What are the different factors in the range you are going to test, right?
Yeah. For April, we should provide that.
Yeah. Okay.
And we could discuss it, of course.
Or it's up to you. If you want to discuss, we can also discuss. If you make some rough, the experiment plan, meaning what are the factors combination you are going to make it, then we can discuss together. Is this house? We can. Is it okay with this?
I guess we will go step by step. First with the 1.2, but out of this first test we have as a result.
And before 1.2, we need a meeting for the discussion of what is the combination they are going to take.
No, the combination is in 1.4, correct?
Yes. Yeah.
Yes. The
For
combination of the scenario is in 1.4.
Right.
Is that clear? What is the outcome of each one for you? Okay.
1.2, what is the outcome?
Please.
It's the impact of each individual parameter onto the process. So okay, if we change the density, if we change the carbon content, if we change that, but only one per one.
One per one. So if you charge the 1 per 1 means, for example, the bulk density with 1.5, bulk density 2.5, bulk density 3.
Yeah.
Exactly.
Just some kind of sensitivity analysis.
Yeah, for that particular specific parameter, we need to keep other things in the constant, right? So other variables we need to assume something, right? No?
That's correct.
Yeah.
So that other variable, what are the other variable? What are the assumptions we are going to take? That itself we need to align, right? No, we don't want, because those other variables, it is also influence in the 1 by 1 variable when we are testing. The other variables also will be influence, right? Because all the variables are interlink each other, right? No. there is an interaction effect. There will be interaction effect. Always will be there, right? That's my.
It could be, maybe not always, but sometimes there could be some interaction.
And in the beginning, also there is a how much level of the quantity of ELT steel that is also will be influenced, right?
Mhm.
So whether we are going to consider the 10% as an assumption or a 30% or a 50%, what should be considered in the assumption? So those are the things I think if we already prepared in advance, then we need to discuss, right? Or what do you think?
Yeah, we could, of course, we could propose a simulation plan to say, okay, we will do this to use this parameter and vary between this and this, and we discuss if it's okay.
Yeah. Okay. Clear.
So this is typically something you guys could do after you've established the base case, then? Huh?
Exactly.
Yeah.
Okay.
Yes.
So the meeting after the base case is ready would be to show what is the selection you made on different parameter sets for the base case based on historical data, and then have the discussion about the simulation plan.
Yes. Properties are input.
So the simulation plan, which week we can discuss then?
After the 4th of April, we could have a discussion.
Then check it.
April, 4th of April.
Base case.
2nd of April, maybe.
Sorry?
The simulation plan. When can we discuss it? So maybe a 2nd of April.
It will take until the 4th of April. You see, it's finishing the 4th.
Oh, okay. Sorry.
First part is
So
the 4th of April.
and 6th. Yeah.
6th is a bank holiday, and then
The 7th in the afternoon for me, or the 8th?
7th afternoon for me is okay.
7 April.
Everyone is okay. 7th April afternoon.
It's fine for me.
Also fine for me.
It's a technical discussion, so I don't need to be. You can keep me informed, but I don't need to be involved. I think so.
So, is there any preference? What time you mentioned, Shailu?
2nd afternoon, meaning after 1:30.
I will book at 2 to 3. Okay.
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 Fine.
Or you, Shailu, you can book it.
Yeah, I will book. So I would invite Christophe and Fran.
Right.
Is there anybody else to be?
Yes.
Fran and Christophe. Okay.
But because we keep on CC constantly the rest of the team.
Okay.
So if they can join, they join. And
Yes.
Okay.
from our side, the same.
Yes.
Same usual suspects.
Yeah. Okay.
And for the
By then we should have, or maybe just most probably before, you will have a clear view on when the samples will be arriving. Correct, Shailu?
Yeah. Most probably, we'll have it.
Expecting that you will have it by then, huh? Okay.
Yeah.
These will be loose samples?
Loose and compacted.
Yeah.
For other part of Gantt, do you have any comment?
But I don't know with the, are we okay with the general timeline? I mean,
Yes.
the sequence of 1 and 2, work package 1 and 2.
Well, what I'm understanding here is that you probably have locked for the second one.
Yeah.
You have looked the lab possibility for the thermal trials for the casting trials from the 20th of September.
Yeah, but
Yeah.
4 months to do 3 casting trials seems quite long.
No?
So I was wondering what the reason behind that was, the 4 months for 2.3. Because these trials, okay, they may not, or they will not be done at the same moment, but I don't know why we plan to spread them over 4 months from the start.
Because of the analysis that they need to run after, or I'm just asking.
Yeah.
Just asking. Yeah.
Yeah, could
Oh,
somebody please clarify why, or what is the reason, or is it just precaution time-wise, or what is it? What is the reason for that?
Yeah, that's why.
Yeah, it would be
Right.
much faster. It just, yeah, in fact, it will depend a bit of the distribution that we will have and the analysis time.
But how do you see the test concretely? I mean, I think we had a decision between the first 2 and then the third one. We would base on the results of the 2 first ones.
Yeah.
So you could say that the 2 first trials could be done, yeah, maybe even in the same week. They are independent from each other.
On the same day.
Yeah, sure.
Even the same day, yeah. And then, okay, you can leave some time between, but I would say, maximum, they should follow. In my mind, but I don't want to simplify it too much. But they should be done in 2 months' time.
Okay.
Otherwise, we will spread them unnecessarily long. And if for time reasons we need to shift a bit, okay. But I think we should plan. And I would ask you to plan, a concrete week already, or 2
Yeah, for a
concrete
more
weeks
exact, for a more
in
exact
the
date.
year that we keep on the radar, and we can follow up, and we all understand that these weeks might shift. That might be the case, but from reasons from Bekaert or from reasons from CRM, because other plannings before that are shifting a bit, or may even advance because the installation is quicker than anticipated. But I would plan really 2 blocks, or 2 dates even.
No, and eventually there are different steps to have the drop down. Better to have more details.
Yes.
And we understand that.
Well, I would foresee in the even 2.3, I would say tests 1 and 2, and then test 3. Put 1 additional line in.
Yes, exactly.
And we try to
make it a little bit more specific.
Maybe 1 extra line, and then we can follow up specifically.
Yes.
And you can put in the column what is it, R, a specific date of that the beginning of that week. But you may not yet have it, but it will, as we proceed, it should appear.
Yeah. Firstly, I put here formal because I see December is quite difficult to organize a test during the period. Because that's I think 4 months, but
it would be that long.
Yeah.
If we have the first trial in September, we do the second one in October.
Yeah, I would like to see them this year even, because we will need some time to do you will need some time for the analysis, and we will need to do some time, or have some time as well, to feed them into work package 2 or 3 then maybe.
Yes.
So, okay.
Okay.
Then I think the overall time I think we need to try to conclude it
started in February.
We started in February?
We started in February.
Well, then the 1st of February or the 31st of January next year, we should try to compact it, and then that's about the 2 weeks that we would take off from 2.3. We should focus by default on a timeline until end of January 27.
Okay.
So,
Benoit, you can check for this to get some dates for the trials?
Yes, of course.
Okay. We'll update its plan. I will send you the new version.
Where you can drop down in terms of different actions or add additional details on what will be done, please don't hesitate also as well to add it. It's a little bit more clear for us to have a little bit more clear view on that.
Yeah. Okay.
So do I understand well then that, for example, then the induction furnace, it is not available until the 20th of September, or because during last discussion,
No.
what was a question mark if we
I did interpret it that way because I thought you were looking to it probably follows some other date. No. Yeah, what was the reason to put that? Yeah, maybe it's a good. I don't know. What was the reason to put the 20th there for now, or it was just you started to add weeks from the 1st of September, the start of work package 2, maybe.
Yeah.
You did. Oh, okay. Well, but I would like to see the 2 weeks that we plan.
But I think right now the furnace schedule is fully open in September. There is
Yeah.
no limitation at all.
Yeah, no. We can even start in the first week of September if
Yeah,
needed. It's more linked if on the vacation of the technician, but normally
September,
I don't have any. It's September normally. Everybody should be back to the work.
the same an hour?
So
time.
Okay.
Usually Alpha Fogius they are there.
Yeah.
Of September.
Well, but if you could check from your side and then maybe update the Gantt chart with
Yes.
that.
Yeah. Okay.
One extra line, two target dates for the weeks that we will organize the trials or plan to organize them.
Okay.
And until end of June, end of January instead of end of March.
Yeah.
Yeah. Originally. It's correct launcher. Okay, I noted.
All right.
Okay, and for another package, work package, it's okay. It's fine. It's okay for you.
Which one do you mean? Well, what do you mean? The work package? Which work package?
For other timeline, it's okay for you, or we need to correct something?
Well, we should take off 2 months at the end, so we should end the end of January.
January, yes.
So we need to compact probably work package 2.
Yeah.
With so 2.3 will be 2 months max. And then the rest will come forward.
Yeah. No problem. Yeah.
All right.
2.4 could be shorter as well.
Yeah, if we
If
we let them know well in advance, I was going to say.
Because that's what I
But this is the whole purpose of the Gantt chart, voila. So I agree. It's possible.
Yes. That's very relevant from the point of view that the material need to be ready for you.
Yeah.
On that time. So the more clear, more precise we see it, of course, knowing that can change, but it helps us to prepare for the delivery of the material.
Yes.
Did we already discuss our quantities of the material that need to be delivered?
How many kilos for
Yes,
the
that was
induction?
discussed already in the previous. This is clear. Okay. I mean, not for the small samples, but for the melting times.
Yes.
I guess it's important we consider also for the next meeting that we start
Alright.
consider because we
Yes.
will need to prepare those material.
Yeah.
Mm.
You need to first check the materials and to have more
Yeah,
sense about the
exactly.
materials before
Mhm.
the next
Yeah,
meeting
indeed.
we will talk about it.
Yeah, indeed. The samples, the first hand samples will be also helpful for that. Okay. Yeah.
Okay.
Okay, is there anything else?
Okay, it's fine for me.
Chris, I suppose you launched or you will try to launch your PO process.
That's my next meeting. That's my next meeting.
Great.
Isabel.
Perfect. No problem.
But so no, I will work on it. But procurement was not available for other things as well in last week apparently, or at least not to me. So I have a next meeting now.
No, but
Yeah.
I just to confirm that from our side, for the team to be able to work, I've already encoded it as if it would have been ordered, and they have their full budget available to do the work. So, but of course, I need to make sure that the document is somewhere available by the time we need to start invoicing, and that is has become a standard practice these days. It is mandatory is a big word. I'm requested to invoice at least an advance payment of 20% on these big orders. So as soon as I have the PO, you will see the first invoice coming immediately.
Okay. All right.
Okay, thank you.
Keep you up to date on that.
Yeah.
Isabel.
Perfect.
Okay.
Okay.
Perfect.
Okay, I will send you the minute and the update of 6 Vulkan chat.
Yes.
It's the end of
All
the
right. Yeah.
Okay.
Okay.
Yeah, please, as much as details on the planning, the best also for us to understand.
Yeah.
Thank you.
Okay.
Thank you.
Okay.
Thank you.
Thank you.
Bye bye.
Bye-bye.
Have a
Thank
good
you.
afternoon.
See you. Bye.
Bye.